Second question on the stats paper, talking about CDFs and PDFs. So firstly, it's important that we know that little f of x is a PDF and capital F of x is a CDF. So this is equal to a given value. This is a cumulative, a running total. So we're given the PDF and we're being asked to work out the CDF in part A. So let's work from the lower x values upwards. So firstly, we know, if I write down my final answer up in this corner here, that my f of x is going to look like this. It's going to be at 0 for any x values that are less than 0. Okay, because we're told 0 otherwise. You're then going to have two parts. One, hopefully I've left myself enough space here, between 0 and 1. Another part between 1 and 3. And then anything greater than 3, the CDF will be 1. Remember, it's a running total, so we're adding up the total probabilities of getting this x value or less. So getting an x value of 3 or less, it covers everything, so it has to be 1. So firstly, let's worry about what's happening between 0 and 1. So between 0 and 1, let's integrate, but with, say, some dummy variable a at the top of it. That's our 0.4x dx. So when we integrate that, we're going to get 0.2x squared between 0 and a. And when we put in that, we get 0.2a squared, obviously 0 there. So for this, it's 0.2x squared. As our CDF, capital F of x, is a running total, once we get to 1 and we start going into this bit, we are going to integrate between, say, 0 and b for our 0.4. But don't forget, as it's a running total, we've also got what probabilities occurred here. Hopefully we can see that when x is 1, put x is 1 into here, you get 0.2. So up to 1, there's a total probability of 0.2. So that has to be added on to our integral. So we then carry it out. We've still got this 0.2, which we mustn't forget. We do our integration, and we put in our bounds. So we get 0.4b, and so that should be a 1, because we go between 1 and 3, subtract 0.4. So when we simplify it, it's 0.4b minus 0.2. So just replace the b with an x, so this bit here should be 0.4x minus 0.2. Just double check, when you put x equals 3 in, do you get 1? 1.2 minus 0.2 is 1. So that's our final CDF there. So that's part A done. For part B, it says hence find the median. So we're looking for f of some value, let's just call it m, the median, to be a half. So we've got to have a little think. Hopefully, looking at this, we can see that we know that any value between 0 and 1, the biggest it could be when it's 1, as we said here, is 0.2. So the median is going to fall somewhere in here. So we want 0.4 m minus 0.2 to equal a half. Move the question out of the way. So hopefully we can then therefore see what 0.4 m is 0.7. So m is 7 over 4, and that's our median. Okay. In terms of sort of working and understanding, you've said this, saying therefore the median is between 1 and 3. Okay, in the mark scheme it definitely mentioned that and said anyone recognising that would gain you some marks. So it's important that you show that information there. So if you know it's a multi-stage CDF, state where the median is. They will give you a mark for identifying that. So try and make sure you're explaining what's going on. So this, okay, you understand what you're doing. Therefore the median's between here, and then solve it.